Sometimes we must use the chain rule when we're using the second part of the fundamental theorem of calculus. This will occur when the upper limit is now no longer just a variable, but now it is a function of x. Whenever we are finding the derivative of an accumulation function where the upper limit is a function of x, we take that function and we plug it in for the dummy variable. Plug in, and then we must then multiply by its derivative using the chain rule, right? Because we have to think about taking the derivative of that upper function. So once again, let's demonstrate why this is even true. So let's say we have this accumulation function, f of x, the area under the curve from 1 to x to the 5th of cosine t dt. If I want to find the derivative, first I need to just find out what f of x is. So in order to do that, I'm going to use the first part of the fundamental theorem of calculus. Well, the antiderivative of cosine t is sine t, and I am going to evaluate that from 1 to x to the 5th. So now I have f of x, let me write f of x each time, equals sine of x to the 5th minus sine of 1. That is using the fundamental theorem of calculus part 1. So now if I'm trying to find the derivative of this function, the derivative of sine is cosine x to the 5th times chain rule 5x to the 4th. And remember, the derivative of sine of 1 is going to be 0 because sine of 1 is a constant. So what we've just shown is that we took x to the 5th, plugged it in for our variable, and then we multiplied by its derivative. So anytime we have an accumulation function that we're trying to find the derivative of, if the upper limit is a function of x, we plug that in for our dummy variable, and we must chain rule and multiply by its derivative. We're going to accept this as true, and we do not have to show any work because we understand the fundamental theorem of calculus, part 2.